Hi everyone, I'm back with another practice problem. In this one, it says transform the circuit in figure 4 from time domain to phasor domain, okay? And then if you look at the circuit, it has capacitor and then current source, voltage source, inductance, etc. Okay, so in order to convert from time domain to frequency domain or phasor domain, we need to remember that an R is going to get converted to an R. A capacitor is going to get converted to its impedance, which is j omega c, 1 over j omega c, and then an inductance is going to get converted to j omega L. Now you might ask, okay, what is omega? Omega is actually defined by the sources you have here, because all of our sources are, this is our 377, this is 377, and then here as well. So our omega from the sources, it seems to be 377. Okay, so this is what we learned from the circuit. So we have two capacitances, C1 here and then C2 here, and then also an inductance. So let's find the impedance of all of these so that we can just replace them. So C1 is going to get converted to C1 is going to get converted to 1 over j omega C1, which is 1 over j 377, and then 2.7 milli, which is 10 to the power minus 3 farad. So this is going to be minus j 1000 over 377 multiplied by 2.7. That's almost minus 1j, almost. Okay, and then we have C2, which is 1 over, it's going to be 1 over j omega C2, 1 over j 377, 1.3 multiplied by minus this. This is going to be minus 2j, almost. And then L is going to be j omega L, which is going to be j 377 multiplied by, our L is 13.3 millihenry. Okay, so now let's do this. 13.3 multiplied by 377 is equal to almost 5. So now we have almost 5j. I'm a little bit of a perfectionist, so I'm gonna correct these. Okay, perfect. So now let's do that. And then we know that in phasor domain, whenever we have cosine omega t, it's going to get converted to 1. Whenever we have sine omega something, omega t, it's going to be j, because we have about 90-degree phase difference between them. Okay, so with that, I'm going to keep, actually, let's make this smaller. So let's do the conversion. I'm going to start from here and then go from there. So we have a voltage source, which is 10 sine of omega t plus 90 degrees. So you already know that it's a sine and it also has 90-degree difference. So it's going to be 90 degrees because of the sine, and then plus another 90 degrees. So it's going to be 180 degrees. So this is going to be minus 10 volt. Or you know that sine is right here, and then you have another 90-degree difference of phase. So it's going to land right here, which is a minus of a cosine. So minus 10 volt here. Then instead of C2, we are going to put minus 2J. Then we have a current source, which is 5 sine plus 45 degree. So it gets 90 degree of phase because of the sine, and then you have another 45, which is going to be 90 plus 45 degree. So it's going to be 5, 135. Okay, and then here we have the inductance, which is going to be 5J. Then we have the resistor. We have 8 ohm here. Then we have C1 minus J. We're going one by one. We have another current, which is 4 cosine omega t. So this is exactly going to be 4. And then 6 ohm. Okay, so it's asking I3, I4. It's asking to write the mesh, or another name is the loop. It's asking to write the mesh current equations or the loop ones. Doesn't make any difference. Whenever you want to write a mesh one, you remember a mesh equation. Remember that you're dealing with voltages. Whenever you have a voltage or an impedance, you can write it. If you don't have these things, then you can't assign a voltage. For example, here, this is a current. You don't know the voltage across it. This is a current source. You don't know the voltage across it. So basically, you can't write a loop equation or a mesh equation in I3, I4, or I2, right? So the only thing you can write for now is, so we can write it in loop 1. But I'm going to tell you how you can replace those equations. In loop 1, let's start from here. We have a minus 10 because of the voltage source. Then we have an 8 ohm multiplied by I1 minus I3 minus 2J, I1 minus I2. This is 0. Now let's look at loop 2. Can I write a voltage equation? No, I can't write a voltage equation, because as soon as I start from here and I rotate, I get here, I don't know what I'm talking about. Like, as soon as I get to this point, I don't know what I should be writing for the voltage. But what I can tell is that from loop 2, I can know that I2 is exactly the current, because I2 is the only one going through this current source. If I2 is going through it like this, I2 is going to be exactly minus of I of the source. Let's call this source 1, for example. This is IS1. So this is exactly minus IS1. So it's going to be minus, or 5, 135 plus 180 because of the minus. I replace the minus with this plus 180. So now it's exactly like 5 minus 45 degrees. Okay, and then now let's go through. So we found I2. I2 is defined. Perfect. This is I2. We're going to use it. Then we have loop 3. Loop 3. Can I write anything? No, I can't write a voltage for it, because again, when I get to this current source. I don't know what the voltage across it is. But what I know from that is that I4 from loop 3, I4, note the direction please. I4 is going up and it's the same direction of the current source. I4 minus I3 is 4 amp. So this is my second equation. I already found I2 and I have I3 and I4 related. Sorry, the third equation. And I have I3, I2, and I1 here. Which again, I can go back and replace this one here, but let's hold it for 1 second. Let's finish the loop equations first, and then we simplify. Now loop 4. Again, can I write loop 4? No, because I have a current source there. I can't. But I already used the relation between I3 and I4. Okay, so how can loop 4 help me? The only way loop 4 can help me is if I bypass the branch between them and create a super loop. I write a super loop from here to here. I start from here. So let's start. Minus j I3 plus 6 I4 plus 5j I4 minus I2, don't forget that, plus 8 I3 minus I1 is equal to 0. Okay, so this is our fourth equation. So we have 1 here, 2 here, 3 here, and 4 here. Now we have to solve this, okay? So in the first equation, if I combine first equation and the second equation, I get this, minus 10. I say 10 and I write 8. Minus 10 plus 8. I can write, let's write it from I1. 8 minus 2j I1 minus 8 I3, and then I take all the knowns to the other side of the equation. 10 plus 2j, sorry, minus 2j I2. So 10 minus 2j multiplied by 5 over minus 45 degrees. So this is going to be, we have to combine the phasors. This is a 90-degree difference. So this is going to be minus 10 minus 2, or 2 multiplied by 5 is going to be again 10, 45 degrees, because 90 plus minus 45, it's 45. Okay, and then we can also replace this by 10 minus 10, 0.7 plus 707 j. So 10 minus minus 7, almost 3, minus 7j. So that's our first equation. 8 minus 2j I1 minus 8 I3. This is our first equation relating I1 and I3. Let's go to combining. Now we're going to combine star 2, the value of I2, I3, and I4. And instead of I4, I'm going to write I3 plus 4. So I can replace everything, I can write everything in terms of I1 and I3. Okay, so again, let's start with I1. What do I have in star 4? I have 8I1. Then let's write it in terms of I2 plus 5JI2. I'm going to first organize it and then replace it. So I already wrote this term and this term, okay? And then I will be writing, that's how you know this should be minus, not plus, minus J2. And then I3, what do I have for I3? I have 8I3. And I already took care of this one. Now for I4, I have 6I4 plus 5J. 6 plus 5J I4 is equal to 0, right? Okay. 8I1 minus 5J. 5 multiplied by minus 45. That's in lieu of, or in replacement of I2. Then 8I3, I'm going to keep I3, plus 6 plus 5J I4, which is I3 plus 4, is equal to 0. So 8I1 is going to stay, and then 8I3 plus 6 plus 5J I3. On the other side, we have 5J, 5 multiplied by minus 45, minus 6 plus 5J multiplied by 4. Almost getting there. So again, J is a plus 90 degrees, and minus 45 is going to be 25. 45 degrees minus 24 minus 20J. 25 multiplied by 0.71, let's say, plus 0.71J minus 24 minus 20J. So 25 multiplied by 0.71, 17.75 plus 17.75 J minus 24 minus 20J. That's minus 6.25 minus 2.75, oops, 2.25 J. So that's 8I1 plus 14 plus 5J I3. Okay, this is the second equation. Now we can write a matrix solution. So we can write this like this. The first equation, 8 minus 2J minus 8. Then we have 8, 14 plus 5J, I1, I3, and then is equal to 3 minus 7J, and then 6.25 minus 2.25J. Kramer's method says you have to calculate 3 determinant, basically. So first, let's call this A. And then determinant of A is going to be 8 minus 2J minus 8, 8, 14 plus 5J. It's going to be 8 minus 2J, 14 plus 5J, minus 8, 8. And then we have another matrix called A1, which is going to be, you have to calculate that. We are going to replace the constant 3 minus 7J minus 6.25 minus 2.25J, and then keep the rest of the A matrix. And this is going to be 3 minus 7j, 14 plus 5j, minus 8, minus 6.25, minus 2.25j. And then we can find I3 by constructing another matrix, which is 8 minus 2j, 8. And this time we are replacing the constant ones, minus 3.7j, minus 6.25, minus 2.25j. And then, so it's going to be 8 minus 2j, minus 6.25, minus 2.25j, minus 8, 3 minus 7j. Did I make a mistake? Yes, this is a plus 3. And this is going to be a plus 3 too. Okay, once we calculate these ones, then I1 is going to be over A, and then I3 is going to be A3 over A. We already know I2, which is 5 minus 45. And then once we found I3, then we know I4 is I3 plus 4. And then you can solve this basically. So it's mostly phasors math after this point. Thank you so much for watching. I hope you learned something, and come back to this channel. Bye.